Hello, we are welcome back again to Daz-Tuition. Today we continue with our tutorials. My name again is Ernest Adazi. Um, we have episode 4, which means we are on task 4, right? Yeah, so my reference, the main textbook we are using here is the Thermodynamics and Engineering Approach, okay, by Eunice Angel and Michael Boyles. All right. So today we try to continue with um, the manometric analysis. Okay. But this time around, in our previous session, we looked at a single pipe, right? A single tank. But this time around, we have two tanks, and sorry, two pipes, horizontal pipes, and they are connected by what? A manometer, YouTube manometer. Okay, we have fresh water and seawater, and they are flowing in parallel horizontal pipelines as shown here. Okay, now we are to determine the pressure difference between the two pipes. You see, it's similar to the previous one, it's the same analogy. This time around, we are looking at pressure difference like we did by saying P1 minus P atmosphere to give us the gauge, right? So we are going to write the governing equation down. After that, we'll find the difference between the pressure and we solved it, okay? And we solve it. So here, we can start with the pressure here. We start with the center here. And then we can also start with the other one here, the seawater. So if we call this, let's say PA and then PB, okay, at the center. Now we are going to look at the pressure difference, and they've given us the density of the seawater to be this, okay, and then in this case we are being asked to ignore the air column in our analysis, okay, but we'll first of all write the generic equation and then we'll take that one out, okay. All right, we know the density of water. We are going to take it as 1000 kilograms per meter what cube, okay, or cubic meters. Are you following? We have all the dimensions given in there. We can see the various dimensions, okay, the data, everything is given, so take note of everything, okay. We have air, mercury, we have fresh water, and we have seawater. Now the assumption, we have all the fluids to be incompressible, okay, of course excluding the air, but here we are assuming them to be incompressible. The effect of the air column on pressure is negligible, okay. So we are going to see. So if we decide to walk through or swim through from this point, remember the pressure on the horizontal line is what? Constant. Are we there? So we start from this level and then we'll move to the, let's look at identify the similar sections where we can easily cancel. I have mercury here. So if I draw this, going down here will cancel going up here, right? And then if I go to the air column, I have here, so going up here will cancel this, okay. So then we have this. So we are only going to consider this small height here, and then the 70, and finally this. So we start from fresh water. So P, remember I said this is A and this is B. So we start with PA, okay, then we'll move downward to the next interface, which is this one. So the pressure will be plus, it will be due to what? The weight of what? The fresh water. So we have the density to be, density of fresh water, let's call it, let's say, fresh times G times H1. Okay, so our H1 will be the 60 centimeters. Then we move on to plus. Is it plus or minus? Let's check. So from here, we are on this interface. We go down and then we go up here. So we are on this point. So to use the other one, we are moving up. Okay, so it's negative. So minus rho of mercury. So rho of mercury times G, let's say times H2. Remember, like I said, we are going to use the 60, which is 0.6 meters. And then this one we are going to consider what? 0.1 meter, because it's in 10 centimeters. So we are now here. So we go up to this point here, which is 70, and is due to air. We are still negative. So minus rho of air G, okay, H3. Remember, H3 is what? 0.7 meters. So I'm here, this will cancel, so I'm still going, they will cancel out till I get to this point. And then from here to here, I'm going down. So down means positive. That will be due to which fluid? Seawater. So rho C times G H4. And the H4 here is what? 40 centimeters, which is 0.4 meters. Then we are at this point here at the pipe center. Remember, it's the same here. So we are at point B. So we just say equals PB. All right. So this is the analysis. Okay. Now they are saying that we should take out, we shouldn't consider, or we should neglect the, what do we call it? The air column. So if we decide to take out the air column, meaning that we are not going to consider this, is out, we are only left with this term, that, and that. So if we were looking for the pressure difference, it could be PA minus PB or PB minus PA. It doesn't matter. Your sign is what is going to change. So if I go for PA minus PB, I'm now, I'm bringing the PB here. So I'm taking everything across. Let's take the negative ones across. So we have rho mercury times G. Now remember, H2 is 0.1. Okay. Then I have fresh, so that will be minus rho fresh water times G. H1 is 0.6. Then I have this term minus, it's across, right? So minus rho sea water G. H4 is 0.4. So this is basically what we have. Now, what I need to do is just to do the substitution. In order to write a lot, I can bring out my G and say I have 0.1 times rho mercury. I always leave it so that you can solve along and enter, okay, to get the values. I have minus 0.6 times rho of fresh water, okay, minus 0.4 times rho of what? Sea water. So simply put output this 9.81 into bracket 0.1. You know the values, so put the values in them and then get me the final answer. Okay, so just we have this and that. Okay, don't worry, I'll show you the final result. Don't worry. So I have this 0.4, then I'll put in the value here, then I get the final answer. Okay, is it clear? I need you to understand the problem first before you solve it. Okay, all right. So by so doing, we just do the substitution like we just did, and then we use the working through before to get the Gamlin equation, and then we do the substitution and we obtain our final answer. So anytime you have a manometric problem, that is how you tackle the problem. Are you getting that? All right. Now, the other piece has to do with the fact that we don't have the air. Okay, now if we consider the air, remember the air will be what? If it moves across, it will be positive, right? So it will be positive. You realize that the effect of the air pressure or the pressure due to the air wouldn't be, can easily be neglected. We'll see later on. So let me clear this and show you the script that we have. So the analysis, like we said, we start from P1.1 and move along the tube by adding as we go down and subtracting as we go up the rho g terms until we reach the sea water pipe, 0.2, right? So in this case, we are calling this 1 and 2, all right? So I need you to understand this. So we have P1 and P2 instead of PA, PB, okay? All right. So I just want you to get the concept there. So P1 plus G dot water, okay? So mercury, we are using Hg. You see where these things are, we considered this, and we now came to consider this. The next one, we consider that, all right? So we have this, and then we go down, minus that. So this should be equal to the P2, all right? Now, we've been given this data. So based on this, we can move ahead and rearrange them nicely by finding the pressure difference, okay, between the two. Now notice something, that we ignored what? The air column when we're rearranging. Look at the next term here. We've taken the air out, right? There's no air term here. So we try to rearrange, and then on substitution, we obtain what? 3.39 kilopascal. I hope it makes sense. 3.39 kilopascal. Now, this means that the pressure in the fresh water, okay, is 3.39 higher than the pressure in the seawater. In the seawater pipe, because of how we rearranged it. So if we had done it P2 minus P1, it would have been negative. So we'll say that one is lower, this amount lower than the one in P1. So you need to know how to interpret your result. It's P1 minus that. So if P1 minus the difference is this, meaning P1 is higher, okay, than that. Now, if we should consider the effect of the air, okay, that's the 70 centimeters, okay. Remember, the density of air is just 1.2 here in our case. Now, so we are going to look at the value, which is 0.008 kilopascal. It is so small compared to the 3.3 value, right? So if we should add it, there wouldn't be any effect, so we can easily neglect it. That's why we ignored it in the first place, all right? If you have any problem, just, before you ask, just try to pause, go through back and forth, okay? If you don't get the concept very well, just leave me a question in the comment section. I'll address each one for you, all right? All right. So do have a good one. All right. Thanks once again for your participation. So we'll move on to the next episode later.